Alright, so welcome to chapter 4. This particular chapter is about something called probability distributions. And there are a few that we'll learn about. So in section 4.1 you can see the topics right here. First thing we want to know is kind of what is the difference between what are called, first of all, what's a random variable? And there are two types. There are what's called discrete random variables and continuous random variables. Okay, I'll show you how to make a distribution. How to tell if something is even allowed to count as a probability distribution. There are two basic rules to tell. And then I'll show you on the calculator how to do some of these things right here, finding mean and variance and things like that. And then the last thing, which is kind of interesting, how to find the expected value. Okay, so one thing I want to mention, the calculator stuff, the audio, I don't have a good calculator emulator on this computer, so I'm going to have to switch to another computer when doing the calculator problems. You can find those videos. It'll be titled, it'll say like example 2 calculator, and I'm probably not going to say too much on those because the audio is terrible. You'll hear like this loud kind of background noise. There's no way around it, but that's where you can find the calculator keys. In these videos all I'll do is I'll show you how to press the buttons, but if you want to actually see kind of what it looks like, I can do that on the other videos, and those will be found in the playlist. Alright, so first of all, what is a random variable? And it's pretty simply defined. A random variable is just the outcome of an experiment. Okay, if I flip a coin 10 times, let's say I flip a coin 10 times, and I am interested in the number of heads. Let's say I get 8 heads. This would be my random variable. Okay, it just represents the value for each outcome. In this case, the outcome that we're interested in this example would be heads. Okay, and as it says here, and we'll talk about the difference in just a sec, an outcome can be either measured or it can be counted. Okay, and that's really the difference between a discrete and a continuous random variable. Okay, when the word random, you probably used this before. If somebody says that was really random, it just means it kind of happened by chance. Okay, there are two ways that things can happen by chance. Discrete random variables are variables that are basically countable. You would normally count them. And continuous random variables are uncountable, and I'll explain why in just a sec, because normally you measure them. Okay, so discrete means that you count, continuous means that you measure. Okay, and if you measure, you might say, why is it uncountable? Can't I count somebody's height? Well, you don't really count their height, you measure it, and we'll see an example of this in just a sec. So here's an example of a discrete random variable, the number of calls that a telemarketer makes. Why is this considered countable? Because you can only, discrete means that there's like a jump between each. After you make one call, the next thing is 2. After you make 2 calls, the next number is 3. You can't make 2.8 calls or 2.7456, 9 calls or something. These are impossible. Okay, discrete means that there are just clear jumps from one number to the next, from 4 to 5 to 6 to 7. You would count the number of phone calls. You wouldn't measure the number of phone calls. Okay, what's an example of a continuous random variable? So let's use the same one. We're a telemarketer calling people. You wouldn't count the number of hours. You would measure the number of hours. Okay, and the answer, the reason why, and you might say, well, you still could count, but the reason why is you could fill in numbers between like 3 and 4, let's say. It's not like if you call somebody and you're on the phone for 3 hours, the only next possibility is 4. No, you could be on the phone for 3.1 hours, or 3.01, or 3.000001 hours. The point is that you could keep carving this up into finer and finer, or more, smaller units, so to speak. You could never count all the numbers between 3 and 4 because there's literally an infinite number of things. Like, notice how we could take this decimal out as precisely as we wanted. So I hope that difference makes sense to you. Discrete means you can count, like the number of phone calls. Continuous means you can measure, like somebody's height. It's not like if you're 6 feet tall, the next option is 7. No, you could be 6 foot. You could be 6 feet 1.1 inches tall, or you could be 6 feet 2, 3, 9, 7, 8 inches tall. There's really no limit to how much you can carve that up, but there is a limit on the number of calls that you can make, for example, or the number of people or whatever. So let's do a couple examples. I think it'll be clear, and that just restates what we just said. So we want to determine whether it's discrete, meaning is it countable, or whether it's continuous, okay, which usually means that you measure and explain our reasoning. So X is the number of companies that lost money. That's going to be discrete or continuous, and hopefully you said discrete. You would not measure the number of companies. You wouldn't say, well, there are 3.278 companies. No, you would say there were 3 companies, or there were 4, or there were 5. You would count the number of companies. Number 2 says the volume of gasoline in a 21-gallon tank. Well, the question is, could I have 3 gallons and then the only possibility that comes next is 4 gallons? And the answer is no. You could have 3 gallons, you could have 3.1, you could have 3.01, 3, 4, 5, 7 gallons. You could measure that as precisely as you want. And because we can measure it, that means it's continuous. All right, maybe 2 more examples. I think we'll get a good picture. So number 1, the speed of a rocket. So let's say 55 miles an hour. Is the next possibility 56, or could we say like 55.1 or 55.03128? And the answer is we could carve it up, we could measure it as precisely as we want. So that is measured data, and if it's measured, it means it is continuous. All right, the next one says the number of calves born. Could we have 17 calves, and then does it go straight to 18, or could we have 17.1345 calves? Well, I hope not. That would be a terrible way to treat the calves. You would not want to have 0.13 of a calf. So that's definitely going to be counted data. You count the number of calves. You don't measure them. And because it's counted, that means we're dealing with a discrete random variable.